Welcome to an extraordinary journey where quantum physics meets ancient history. Today, we'll explore how researchers at the University of Bologna have developed a groundbreaking technique using quantum nanotechnology to read carbonized scrolls from Herculaneum without unrolling them. This remarkable innovation could unlock thousands of texts thought lost to history, potentially transforming our understanding of ancient Mediterranean civilizations. Join us as we delve into this fascinating intersection of cutting-edge science and classical antiquity. Last month, researchers at the University of Bologna's Center for Advanced Papyrological Studies announced a revolutionary non-destructive imaging technique that has sent shockwaves through both the scientific and archaeological communities. This cross-disciplinary breakthrough uses quantum nanotechnology to reveal previously unreadable text on carbonized ancient papyri without physically unrolling them. What makes this discovery particularly significant is how it bridges the seemingly disparate worlds of quantum physics and classical antiquity, creating a paradigm shift in archaeological conservation methods. The technique emerged from an unlikely collaboration between quantum physicists, materials scientists, and classical philologists who connected during an interdisciplinary conference in Milan 3 years ago. What began as a speculative conversation has evolved into one of the most promising archaeological tools of the 21st century, demonstrating the remarkable potential when different scientific fields converge to solve historical mysteries. The carbonized scrolls of Herculaneum have long been one of archaeology's most tantalizing mysteries. These ancient texts were preserved when the Roman town was buried alongside Pompeii during the catastrophic eruption of Mount Vesuvius in 79 CE. Discovered in the 18th century, these papyri were transformed into charcoal-like cylinders by the volcanic heat, making them extremely fragile and virtually impossible to unroll without destruction. The Villa of the Papyri in Herculaneum has yielded over 1,800 scrolls, most of which remain unread due to their delicate condition. Historians believe these texts could contain lost works of Greek philosophy, poetry, and science, potentially including missing dialogues of Aristotle, plays by Sophocles, or scientific treatises from the Alexandrian period. Previous attempts to access these texts using various imaging technologies have yielded only limited results, revealing fragments while leaving most content inaccessible. The carbonization process created what researchers call the perfect archaeological paradox, preservation through destruction, as the very event that saved the texts from decomposition also made them nearly impossible to read using conventional methods. The fundamental challenge with reading these scrolls has always been one of contrast. As Dr. Elena Marchetti, the lead physicist on the project, explains, both the writing material and the substrate are carbon-based, making differentiation exceptionally difficult with conventional techniques. This similarity in chemical composition between the ink and the papyrus itself has thwarted even advanced technologies like X-ray phase contrast tomography. The carbonized scrolls are extraordinarily delicate. Many are less than 0.3 millimeters thick with multiple layers fused together. Traditional unrolling attempts destroyed many scrolls in the past, while even the most advanced imaging techniques struggled to distinguish the carbon-based ink from the carbonized papyrus background. This technical challenge has prevented scholars from accessing what could be some of the most important literary and philosophical works of antiquity, creating a frustrating situation where priceless knowledge remains locked away in plain sight. The breakthrough came from an unexpected source: quantum technology primarily developed for next-generation display screens and solar panels. Quantum dots, semiconductor nanocrystals typically 2 to 10 nanometers in diameter, exhibit unique optical properties governed by quantum mechanical effects. The research team synthesized specialized cadmium selenide quantum dots with precisely tuned band gaps that can selectively bind to trace metallic elements in ancient inks. Even the most seemingly carbon-based ancient inks contain trace metallic impurities from their production process, notes Dr. Sanjay Patel, a materials scientist on the team. These impurities are like invisible fingerprints that quantum dots can reveal under the right conditions. The quantum dots function through a process known as size-dependent quantum confinement, where their optical and electronic properties change in response to their dimensions. By engineering quantum dots to specific sizes between 3.2 and 4.8 nanometers, the team created particles that selectively interact with specific metallic ions present in ancient inks. When excited by ultraviolet light, these quantum dots emit visible light at wavelengths easily distinguished from background fluorescence, creating high-contrast images of otherwise invisible text. What makes this approach revolutionary is its extraordinary sensitivity. The quantum dots can detect metallic traces at concentrations as low as 10 parts per billion. far beyond the capabilities of conventional imaging technologies. The process involves carefully exposing the scrolls to an aerosol containing quantum dots suspended in a non-reactive solution. After application, the scrolls are illuminated with a specific wavelength of ultraviolet light, causing the quantum dots to fluoresce only where they've bonded to metallic traces in the ink. A specialized hyperspectral camera captures this fluorescence, producing high-contrast images of previously invisible text. The implementation requires precise environmental controls, with temperature maintained at exactly 19.5 degrees Celsius, plus or minus 0.3 degrees Celsius, and humidity at 42%, plus or minus 2%. The scrolls are placed in a specialized chamber where the quantum dot aerosol is introduced under positive pressure to ensure even distribution without mechanical stress on the fragile materials. The entire imaging process takes approximately 18 hours per scroll, including preparation, imaging, and removal of quantum dots. A critical aspect of this new methodology is its complete reversibility. We've designed the system to be completely reversible, emphasizes Dr. Alessandro Bonelli, the team's conservation specialist. The cardinal rule in archaeological conservation is, first, do no harm. Our method adheres to this principle while still providing unprecedented access to these texts. After imaging is complete, the quantum dots can be removed entirely using a gentle vacuum process followed by a controlled humidity chamber, leaving no permanent residue on the artifacts. This non-destructive approach represents a fundamental shift in archaeological investigation, allowing researchers to access information without compromising the physical integrity of priceless artifacts. The technique respects both the material and historical value of these ancient texts, setting a new standard for ethical archaeological research. By ensuring that future generations of scholars will have access to these materials in their preserved state, the team has balanced the immediate desire for knowledge with the long-term responsibility of conservation. The team has already made significant textual discoveries using this technique on a small test scroll fragment. They've uncovered a previously unknown philosophical discourse possibly attributable to the Epicurean philosopher Philodemus, discussing the relationship between perception and reality in terms that suggest a more sophisticated epistemological framework than previously attributed to the Epicurean school. Additionally, they found references to astronomical observations that may help refine ancient Mediterranean calendrical systems, including specific measurements of lunar phases that indicate a more accurate understanding of celestial mechanics than historians had previously believed existed in the 1st century CE. Perhaps most surprisingly, the texts contain technical vocabulary suggesting advanced understanding of mechanical principles, including terms that appear to describe compound pulley systems and hydraulic mechanisms previously thought to have been developed centuries later. What makes this particularly exciting is that we're not just reading these texts. We're developing a completely non-destructive methodology that can be applied to thousands of carbonized fragments previously considered unreadable, says Dr. Marco Rossetti, the project's lead papyrologist. The implications of this technology extend far beyond the scrolls of Herculaneum. The technique shows promise for damaged medieval palimpsests, where text was scraped away and written over, water-damaged documents from shipwrecks and flooded archives, fire-damaged materials from libraries and historical collections worldwide, and archaeological textiles with degraded pigmentation. Perhaps most intriguing is the potential application to the Dead Sea Scrolls, where numerous fragments remain undeciphered due to degradation. Preliminary tests on non-historical replicas suggest the quantum dot technique could reveal text on these fragments while preserving their integrity. With funding recently secured from the European Research Council, the project will expand to examine larger collections of carbonized materials from sites across the Mediterranean region. The team is currently developing a portable version of their system that could be deployed directly at archaeological sites and conservation facilities worldwide. They're also exploring quantum dots with different binding affinities to reveal other types of ancient inks and pigments, potentially opening up even more historical documents to modern analysis. We're just scratching the surface, Dr. Marchetti concludes. The quantum properties that make modern display screens vibrant are now helping us read words written nearly 2,000 years ago. It's a beautiful convergence of ancient wisdom and quantum reality. This breakthrough exemplifies how cutting-edge science can illuminate our most distant past. As quantum technology continues to evolve, we may find ourselves in a renaissance of historical discovery, where texts once thought lost forever return to enlighten our understanding of human intellectual history. The quantum dots that illuminate our modern screens may ultimately shed light on the thoughts, discoveries, and stories of those who lived millennia before such technology was even imaginable. This convergence of ancient and modern represents a testament to how knowledge transcends time when innovation meets reverence for the past. The research demonstrates that sometimes the most advanced scientific tools are precisely what we need to connect with our historical roots, creating a bridge across millennia through the unlikely medium of quantum physics. The research team isn't resting on their initial success. With the proof of concept firmly established, they're now focused on scaling the technology to address larger collections of texts. The portable version of their system currently under development will democratize access to this technology, allowing smaller museums and archaeological sites to benefit from these advanced imaging techniques. The team is also exploring modifications to their quantum dot formulations to detect different types of pigments and inks used across various historical periods and geographical regions. Additionally, they're developing machine learning algorithms to assist with the reconstruction of damaged texts, using pattern recognition to suggest likely completions for partially preserved passages. The interdisciplinary nature of the project continues to expand, now incorporating linguists, historians, and computer scientists alongside the original team of physicists, materials scientists, and philologists. This collaborative approach promises to yield even more significant discoveries as the project progresses, potentially revolutionizing multiple fields of historical study simultaneously. Behind this groundbreaking technology are the human stories of passionate researchers who cross traditional disciplinary boundaries. The chance meeting at the Milan conference that initiated this project highlights how scientific breakthroughs often emerge from unexpected connections. Dr. Elena Marchetti, whose background was in quantum optics for telecommunications, had never considered archaeological applications until a conversation over coffee with Dr. Rossetti, who had been struggling with the limitations of existing imaging technologies. Their collaboration, initially viewed skeptically by colleagues in both fields, demonstrates the value of interdisciplinary thinking in solving seemingly intractable problems. The team members speak of late nights in the lab, failed experiments, and moments of doubt before the breakthrough finally came. Their persistence in the face of technical challenges and institutional skepticism serves as a reminder that scientific progress often requires both technical innovation and human determination. This human element, the curiosity, creativity, and collaboration of researchers from diverse backgrounds, is ultimately what transformed a theoretical possibility into a practical technology with profound implications for our understanding of human history. The quantum dot technology developed at the University of Bologna represents one of the most significant archaeological breakthroughs of the 21st century. By bridging quantum physics and classical antiquity, researchers have created a non-destructive method to access texts that have remained silent for nearly 2 millennia. The discoveries already made, from advanced Epicurean philosophy to surprising astronomical and mechanical knowledge, hint at how much of our understanding of ancient civilization may need to be revised as more texts are revealed. This technology demonstrates how our most cutting-edge scientific tools can connect us more deeply with our historical roots, allowing ancient voices to speak again without compromising the physical artifacts that carry their words. As the project expands to other historical documents worldwide, we stand at the threshold of a potential renaissance in historical discovery, where quantum mechanics, a science that reveals the fundamental nature of reality, helps us understand how our ancestors perceived that same reality thousands of years ago. In this remarkable convergence of past and present, we find a powerful reminder that human knowledge is a continuous thread stretching across time, waiting for innovations that allow us to strengthen those connections and learn from those who came before us. Thanks for watching. Please like, subscribe, and hit the bell icon for updates. Your feedback is appreciated. We hope to see you again.